This is Dave, and this is the most colorful animal at the aquarium. It's 4 inches long. It looks like a swimming jewel. Dave wants to touch it. Dave thinks it's a shrimp. Dave is about to learn that it is a loaded weapon, because this little thing throws the fastest punch on the planet, and the part that actually hurts isn't even the punch. Today we find out what that feels like. Dave volunteers. Dave always volunteers. First, meet the animal. This is a peacock mantis shrimp. It is not a shrimp, and it is not a mantis. It's a stomatopod, a predator that split off from the rest of the family tree 400 million years ago. That's before dinosaurs. This thing was perfecting violence before trees existed. There are over 400 species. They come in 2 flavors, spearers and smashers. Spearers stab soft prey like fish, fast but normal. We don't care about them today. We care about the smasher, because the smasher doesn't stab, it hammers. Its weapon is a swollen, club-shaped limb tucked under its body, a biological sledgehammer it keeps folded and loaded. In the wild, it uses that hammer to crack open snails, clams, and crabs. Armor that should be unbreakable. To this animal, a hard shell is not protection. It's a snack in a locked box. Now, Dave's finger is not armored. Dave's finger is soft, and Dave is still pointing it at the tank. So how bad can a punch from a 4-inch shrimp really be? To answer that, we have to talk about speed, and the number's going to sound made up. It isn't. We measured it. Watch. A muscle can only contract so fast. No animal can throw a punch this quick using muscle alone. It's physically impossible. So, the mantis shrimp cheats. It doesn't punch with muscle. It punches with a spring. It slowly winds up a built-in spring shaped like a saddle, locks it with a tiny latch, and waits. All that energy, just sitting there. Then it releases the latch. And physics takes over. The club swings it up to 23 meters per second, around 50 miles per hour, underwater. That's a highway speed, coming from an arm the size of a grain of rice, through water, which is much thicker than air. But speed isn't the scary part. The scary part is the acceleration. This club accelerates at 10,000 times the force of gravity. That's the same launch acceleration as a bullet leaving a gun. Same league, same physics. The whole strike is over in under 3 milliseconds. Your eye blink takes 300. So the strike happens about 100 times faster than you can blink. You will not see it, you will only feel the aftermath. Dave, of course, is confident he can pull his hand back in time. Dave cannot. We'll get to why his reflexes are a joke later. Because here's the twist nobody expects. The punch is only weapon number 1. Weapon number 2 is made of water, and it's worse. Here's something nobody tells you. The mantis shrimp can hit you without touching you. To understand how, you have to watch what the water does when the club moves that fast. When the club rips through the water at 50 miles an hour, the water behind it can't keep up. It literally can't fill the gap fast enough. So the pressure drops so low that the water tears itself apart and boils. At room temperature, a pocket of vapor appears out of nowhere. This is called cavitation, a bubble of nothing, born from speed alone. And a bubble like this does not float away peacefully. It collapses violently. The surrounding water crushes it inward and slams it shut, releasing a second shockwave, a second punch, made entirely of water. Researchers proved this with cameras shooting 100,000 frames a second. They saw 2 impacts, not 1. First, the club lands. Then, half a millisecond later, the bubble detonates in the exact same spot. On average, that second hit carries about half the force of the punch, which sounds survivable. But on a good hit, the bubble can deliver almost 3 times the force of the original punch. The water becomes the bigger weapon, so even when this animal misses, it still hits you. The water finishes the job, and the collapse of that bubble does something almost impossible. For a fraction of a second, it gets as hot as the surface of the sun. We're not exaggerating. Let's stay on that. The water near Dave's finger just hit the temperature of a star. When that bubble collapses, the gas trapped inside gets crushed so fast the heat can't escape. It compresses into a tiny, blistering point. Inside that point, temperatures are estimated between 5,000 and 10,000 Kelvin. The surface of the sun is about 5,800. So yes, that math checks out. Before you panic for Dave's finger, there's a catch. This heat is unbelievably small and unbelievably brief. We're talking a spot smaller than a speck of dust, lasting for trillionths of a second. Dave's finger does not catch fire. But that collapse does more than make heat. It makes light. The dying bubble emits a real flash of light. Scientists have a name for it: sonoluminescence, light, made from sound and collapse. Now the myth says this flash is a visible underwater strobe. That is not true. The real flash is far too faint and far too fast for your eye. It takes lab cameras to even prove it's there, but it is there. So a flash of light, the heat of a star, and a shockwave from a shrimp in an aquarium, and that shockwave is loud. The collapse can scream past 200 decibels underwater, louder than a gunshot in air. Dave can't hear it, can't see it, and can't feel the heat. He'll only feel one thing: pain. Speaking of which, it's finally time to let it hit him. So Dave finally taps the glass, and the shrimp decides Dave is a threat. Bad combination. Let's say he reaches in. Let's say it connects. What actually happens to his hand? First, the force. A single strike can land up to 1,500 newtons. That's like the full weight of a grown man, focused onto a point smaller than a pencil tip, on soft skin. Aquarium handlers already know this. The Smasher has a nickname in the trade: the thumb splitter. And the nickname is not a joke. It is a clinical description of what it does. Let's go inside the hand. No blood, just an X-ray. Here's what 1,500 newtons does to soft tissue. The strike crushes the tissue at the contact point. Capillaries burst. Deep bruising spreads under the skin instantly. The flesh can split open down to the bone. This is where the suturing and surgery part comes in. And if it lands on one of the tiny bones in the hand, that bone can simply break from a 4-inch shrimp. Then, half a millisecond later, the bubble collapses on the same spot and does it all again. One strike, 2 impacts. Crushed tissue, split skin, a possible fracture. From an animal Dave wanted to pet. But here's the question that should be bothering you. Why doesn't the shrimp break its own arm? It just hit Dave with the weight of a man. Newton's third law says that force comes right back. That arm should shatter on the very first punch. It doesn't, not after thousands of them. The reason is the club itself. It might be the toughest natural material we've ever studied. It's not solid bone. It's built in layers like body armor designed by evolution. The outer layer is packed with the same mineral that's in your bones and teeth, arranged in a herringbone weave. When it hits, that surface actually flexes a little, like a marshmallow, absorbing the shock instead of cracking. Under that sits the clever part: layers of fibers, each one twisted slightly from the one below it. A spiral staircase. If a crack tries to spread, this spiral forces it to twist and turn until it runs out of energy and just stops. And around the sides, tight bundles of fiber wrap the club like tape around a boxer's fist. That wrapping stops the club from bursting apart sideways when it slams into a shell. So the myth that it would just hurt itself? Wrong. This arm is engineered to never feel its own punch. It's so good that the military studies it, to build lighter body armor and tougher helmets. A 4-inch shrimp is quietly designing the future of armor while sitting in a pet store. But there's still the wear. Even perfect armor takes damage. So every few weeks, it just sheds the whole weapon and grows a fresh one. Of course it does. Which leaves one last thing, the part Dave's been betting his fingers on this whole time. This whole time, Dave's been sure of one thing. If it strikes, he'll just pull his hand back. To kill that idea, we have to talk about the one part of this animal we haven't touched: its eyes. You have 3 types of color receptors. 3. That's how you see every color you've ever seen. The Mantis shrimp has up to 16, plus channels for ultraviolet light you can't even imagine. It even sees a type of light called circularly polarized light. It's the only animal alive that can. Here's the twist though. With all that hardware, it's actually pretty bad at telling similar colors apart, because it doesn't think about color. It doesn't compare anything. Each receptor just fires like a barcode scanner. Instant. No thinking. And that's the whole point. It traded rich color for raw speed. No brain lag. Just see, lock, fire. Each eye also judges distance on its own, using 3 points of view in a single eye. It aims perfectly without even trying. So now put it together. Perfect aim, a spring-loaded hammer, and a strike that lasts under 3 milliseconds. Now Dave's reflexes. From the moment his eye sees danger to the moment his muscle reacts takes about 200 milliseconds. The strike takes under 3. Dave is almost 100 times too slow. This is the answer to the whole video. video. By the time Dave's brain even sees the arm move, the punch is done, the bubbles collapsed, and the weapon's already back home. And remember weapon number 2? Even if Dave somehow dodged the punch, the collapsing bubble was always going to hit him anyway. That's the secret this whole video was built on. The real weapon was never the punch. It was the water the punch leaves behind. You can't dodge water. So Dave keeps all 10 fingers today, mostly because he finally chickened out at the last second. Tell us which animal Dave should survive next. He's already regretting it.